For Victor, yeah, Victor, you should be able to present now.
Thank you. Can you hear me? Can you hear me?
Yes,
Okay. Going to. Can you see my presentation in full screen?
yes, thank you.
Okay. Well, thank you for the time. Glad to be joining you today, the first time. Um, Hope here I can share some relevant cases that we've seen regarding intermodal, particularly in planning and optimization. Um, yes, Dassault Systems, most of our practice in planning and optimization comes from the Quintic acquisition. We've been in the market for almost 2 decades, and doing planning and optimization projects across different segmentations, different segments of transportation, passenger and cargo, particularly cargo. We've done projects in air cargo, in postal and express, in intermodal and rail freight, many references, and so on. Now, across all these projects and across different segments, there are similarities and patterns when it comes to planning transport operations. And all of these segments, whenever we need to account for how operations work, they all have a fleet of vehicles, fleet of units that you need to plan in order to provide a service. You need to create a route. You need to account for maintenance. In all these cases, you have a crew as well that you need to account for in terms of skills, terms of vacations, rosters, assigning tasks, schedules, and account for labor regulations that are different on each country. All of these cases, you also have different facilities that you need to account for. There are assets and personnel that have limitations and have rules. And so all of these put together, you can create then a service plan. You can create a service level. You can define a price. All of this you need to be monitored, controlled, have visibility, keep it under compliance for emissions and safety, and basically you have an operational working. So, but out of all the different cases that we've done, let's say vertically or horizontally on different segments, there's a couple of them I want to share with you particularly. One of them is that we did with Van den Bosch Transporten. I believe is relevant for this audience in the sense that it's planning of cargo. In this case, it's bulk. This is planned into ISO tanks to customers across Europe. This involves the assignment of orders into the right equipment, so that means trailers, containers, and then assign into the right trucks and drivers. So this includes also considering specific rules for contamination and cleaning for each of the ISO tanks. So the plan considers trucks, trailers, chassis, and containers. But an interesting note as well is that one of the project stakeholders from Van Bosch Transporting was that everyone instinctively wants the most sustainable solution, but only if it is also the most cost effective. So the point is how to make it sustainable but also cost effective at the same time for everyone to buy into it, right? And I think it's an interesting case as well because if we think about it under the guises of physical internet operation, for example, we would need to account as well for empty containers. How would these be used across a network, for example? So this, in theory, should be openly usable by any other player across the network, right? Just like any other asset or infrastructure, so that empties could be reused as well by any other operator. But if that was the case, we need to account as well for the history and the cleaning rules for each of those containers if it's to be reused by the network. So there needs to be a memory, let's say, for these type of cases. And the second case that I think would be even more relevant for this audience is a project that is working in the port of Rotterdam, or Next Logic, which is the arm in this case. Port of Rotterdam, as you know, is the biggest container port in Europe. 40% of the share is hinterland transport, and that there's actually 18,000 barge calls per year. And the interesting part is that there's 6 calls on average per visit for each of the barges. The problem that they were having is if you've been anywhere close to the port of Rotterdam is that it's huge, it's massive, and it has even now with the Maasvlakte 2, which is an extension. A lot of the planning being done was being done manually by via phone calls, and there were complaints, of course, that the plans are unreliable. Complaints that the planner spent 20% doing a plan and then 80% spent replanning because there's so many independent players accessing a common set of hubs, in this case, of different terminals. And so the project involved how to bring together the seaport terminals, bring together empty depots, and barge operators across the different terminals in the port of Rotterdam. That was really the puzzle that they were trying to solve. So very cleverly, the team of NextLogic in the port of Rotterdam thought of these integrated planning platform with a few interfaces where we consolidate data from terminal depots and barges in terms of rotations, in terms of where the containers were positioned, crane capacity, when the containers would be released, quay and crane availability. And with this then defined was a schedule for each terminal operator and for barge operators when to access the port of Rotterdam because that would then help reduce congestions within the port, help reduce the time spent by the barge operators standing, reducing traffic, that's one, and reducing time idle, the time spent in the port. That was the second one. So it was a very successful project. It took a few years to test it and roll it out. And now it's on a phase that it will be open to open sea, not just hinterland. And at this point, there's more and more players joining this effort. But five different terminals that the last update is over a year or two, perhaps there are more. Five terminals like ECT, Euromax, APMT, ECT Delta, depots and barge operators, over almost 20 or more than 20 by now, barge operators. So just to give an example of how, in a similar fashion, you could have different players accessing a different common set of assets, but coordinated by an independent entity, in this case, where this optimizer would create the best plan um, without giving preference to any of the players. And actually, the next slides will deep down a little bit more some of the things learned from this case. And number one is, yeah, we always talk about data being important, and there's all sorts of data. I think some of the other presenters have spoken about it, but I think the data in the end has to be used in the context of what do we expect the model to do. And I think that is one of the first questions we need to ask ourselves, like what is the scope of what we envision as a solution? And this output, what we would be thinking is, for example, to reduce overall emissions, for example, minimize distance travel, or minimize asset utilization, minimize late orders. There can be a combination of those, of course, not just one, but depending on what is then the output expected, that is then the scope, and defines the model. And from there, we can really filter which is the right data that has adding value to the model. Not all data is really relevant. And so that is one of the first lessons, so that we don't drown on data, but also we have enough to have a reasonable result out of the model. That is one. Oh, sorry, wrong button. Um, the second one brings me to the point of how do we define that outcome? And in all of our projects, in all optimization projects, um, the models need to be parameterized or need to be tuned. And the quantifiable way to do this is by selecting KPIs or the right KPIs of operations that usually come in the form of KPIs of cost, KPIs for efficiency, KPIs of asset utilization, time utilization, capacity utilization, CO2 emissions, or other equivalent, usually are KPIs of that sort. And that is really important in order to define clearly and among all the players which are those KPIs that we're interested in the model to work on. But just as the right KPIs are important, also are the constraints that the model needs to have. As any optimization model, we're going to have an objective, but there are also going to be restrictions to it. And those constraints, there are classified as hard constraints and soft constraints. Hard constraints, it's, for example, limitations in terms of capacity or infrastructure. Soft constraints could be when you could be late, for example, for 5 minutes. Um, but this is interesting as well, and I think relevant as well to define the right KPIs among all players, as well as the right constraints, hard ones and soft ones, because we've seen, for example, that in some players account for planning capacity, for example, on their vessels for overcapacity. They purposely plan for overcapacity because they know that they're going to have a lot of booking cancellations, and so they expect that to be intrinsic in the model, for example. But that's a practice, for example, that many would not follow. So in some cases, some may do it, others might not do it. When we're talking about a common model that will apply to everyone, these things need to be ironed out, let's say, between all players to agree on which would be then those constraints, hard ones, and the limits of the soft constraints as well. Um, and lastly, of course, I suppose that the KPIs, the more important ones that we would be looking into, for example, be around sustainability. Um, and it's important that we choose the right KPIs. If we don't consider the right KPIs, if we choose the wrong KPIs, for example, then the model, the result that the model gives is not going to bring any value, right? If we don't use accurate data, then the plan is not feasible. Or if a constraint is ignored, is the same case. The plan is not usable. So there are many consequences of not choosing the right KPIs, of not choosing the right constraints, or not defining it correctly for the right level of detail, or ignoring the right ones. So that's the other lesson. And that leads me to two questions that I wanted to share with you that are more conceptual. There are two topics. One of them is whether we think that a single solution model could help plan and solve everything. And this is because within a network there are propagation effects. Think, for example, what happens when a train is late in a single track infrastructure. Everything is pushed out and delayed. The effects are huge. What happens if a truck is late and you're expecting a load that will go to a crossdock and there's another truck that will need to depart? Well, in that case, maybe that part of the cargo would not arrive and you may deliver incomplete, but the rest of the plan goes according to what was scheduled. In the case of the train, that's not the case, right? What happens when a plane is late? Well, they might miss their slot and they might get a one soon after. But so the effects of propagation in a network can be considerable if it's not properly decoupled, let's say. There is not much documentation actually that we have found on this topic. So a lot of the project we have done on aviation, on rail, on road freight, etc. A lot of has come with empirical knowledge and discovering what works and hasn't worked. Um, Thinking in which case it makes sense and it's possible to decouple the model, that what can be made into separate models, and that the output of one becomes the input of another model. For example, on a hub and spoke model where you have regional networks and a main long haul network, that helps decouple and makes a plan manageable, feasible. You see this in practice in many places. For example, in sea freight, you have sea freight routes, corridors, and you have the feeder networks, for example. That's basically almost a hub and spoke. You see this as well in aviation or in postal and express. You have regional centers, and then you have long haul centers or intercontinental centers. So you see it everywhere, and it has a reason and a purpose. Also, why when you plan these type of networks, you don't plan for the activities within the hub. You plan the activities of the transportation, but not exactly what happens inside the hub, because that's a different headache, right? So you want to disconnect one from the other. So that's one of the topics that I wanted to share here. And lastly, one second topic to think about to my final point in the presentation, which is in operations, in logistics, operations and planning, we account normally for different time horizons. Um, we usually, when we talk about route planning and route optimization, everyone is referring normally to the operational planning side, the one in the middle, which is you have an order, you have a customer, and you need to move it from point A to point B in an optimal way. This might happen a few hours or days, and normally projects start around somewhere there, and time of execution, which is on the day of operations, and somewhere in between. Normally, that's where project starts. And I think it has been a bit undervalued the value that brings to have a tactical plan and it's a strategic plan on the part of that. So a tactical plan, you could think of it, let's say, as a brownfield scenario where we can think with a forecast, how would the network behave, let's say, in a peak season? And then there's certain things that I can do in order to cope with those changes. I may hire some temporary resources, hire additional subcontractors, and so there's a few things that I can do in order to cope with that and have less disruptions on my day of operations when that time comes in. So the tactical planning helps a lot with that capacity allocation. And even more so, when we look long term, that we may see it even as a greenfield, let's say, model, where we can think as well with a forecast, but even further, let's say 5, 10 years. Where would those volumes go if we plot those into our network? Let's say a digital twin or a virtual twin of our network, where would those volumes flow to? Where would I have bottlenecks? And here we would have a bit more freedom to play with a model to say, okay, well, what we could add another hub, right? What if we extend the capacity of an existing hub? What if we merge these two hubs? What if we open another trade lane here? And see what are the consequences. So it's a bit more, as I say, like greenfield, and it allows us to play about a bit more many times is underlooked at this type of model, but brings huge benefits long term. We're seeing more customers approaching us with this case, and we've done this for either, let's say, with a tier one rail freight operator in North America to we've done this with a whole country's postal company for the planning and delivery of parcels and letters. The question is, what if we focus on a strategic level first? It has a big advantage, has a great benefit in the sense that it's a centralized effort to do this type of planning project because it doesn't require when we're doing operationally, we normally have to have a rollout, and it has a lot to do with change management, which is something that is overlooked, and it's a reason why projects fail. In this case, strategic planning or a network virtual twin could help also with a faster implementation in that sense. In such a model, we can integrate data from different sources. We can model locations, facilities. We can simulate any attributes from those facilities, and for that transportation, we can simulate flows. We can simulate disruptions. What if we change the policy? What if the working contract in such country changes to 4 days per week instead of 5? How would that change in terms of my capacity, in terms of my cost, in terms of emissions? We can run different scenarios. We can test different changes in technology. For example, in the hub, what happens if I change the technology, cranes or robots in such a facility? How would that change the efficiency in the hub, for example? So it has a lot of benefits, we believe, to think about. That was the last point that I wanted to share with you. I hope these triggered some thinking, some thoughts, and this could be useful for you. That's the end of my presentation. Thank you for your time.
Thank you, Victor.